welcome. Now we're going to do lambda calculus. I'm just going to edit this. And that's number 18. 18th. Done. Introducing stories 3 days ago. Dapster. XR transcripts. Mangled. There's also here. So we're going to be doing lambda calculus. Okay, I was doing Nick streaming. Yeah. Okay. So we are listening to Alka Crab game music, 30 fantasy open world ambient tracks game music pack, no copyright, which is nice. So true and false. Now, I'm almost afraid to do the and again because no, I'm not afraid, but yeah, we've been doing and, the binary operator of the form. Because I feel like if I redo the end now, it will be one more stream. But it would be nice to repeat. It's so hard. I feel like you have to do this every day for a couple of years. Yes, and then you'll know lambda calculus. Simplifying the inner body. So this is what we've been doing. This is the and. And true for values P and Q. And we've defined and in terms of, okay, first we define and like this. Takes two heads, X and Y. Well, because it takes two things and takes two things and does something with them. And the body of the function. Well, the name of the function is and the body, it has two heads, X and Y. And what it does, so these are the parameters of the function. The P and Q that we are going to provide it are the arguments to the functions. You could say these are the parameters of the function. And this is the body of the function, which says that cond y false x. And of course, cond is make pair and false is select second. And what? X, Y, cond, Y, false, X. Make pair, Y, select second, X. So, okay. So we expanded now on the body itself here, which is E1, E2, C, E1, E2. That's the make pair. It makes a promise that it will make a pair, but it does need a function C that will do something to that promised pair, which in our case is going to be select second. So the make pair of what? Y. So he's making a pair. It's funny when I look at it now. Oh my God, I'm going again through this thing. So it was easier before. This is actually a totally, again, this is a new abstraction layer because now I have to reuse in my head. The make pair was not hard because the make pair was simply making a pair. Look, this is not hard. We have one head, we have second head, we have third head. And here it's still the same level. It just says that this is going to do something to these two heads. But now the body itself is way more complex. It does have other function definitions inside of it. And the substitution rules are now still applying, right? But since each of these function has a body of its own, we have to substitute the arguments for the parameters of the function body and do the entire thing until we get this more simplified. So we're not actually even solving it, we're kind of simplifying, reducing, I guess. We are reducing the function body itself without any values. So we are still not providing any value. We are reducing a function body. So we have the make pair here. Again, E1, expression 1, expression 2, and a C a function. So C will be applied to E1, and then that will be applied to E2. Y, and select second, and X. Select second is, it takes two things and gives back the second thing, which in our case is false. Now, what are we doing here? Okay, we're substituting Y for the E1. We get E2, C, right? Y, because E1 is here. So we substitute Y here. So the argument Y goes into the parameter E1. We remove the head. So we get E2, C, Y, E2. Select second, X. And now we're going to do with the select second. So we are, as you can see, this is the way function application works. Now this is going to be applied to select second. So this entire thing is applied to select second. How? We substitute again. So this is constantly this theme going on with functional programming. So we're substituting our arguments for the parameters of the function inside of the function body. So now select second goes inside of C. No, inside of E2. We have an E2 now. E2, C, and C, Y, E2. Y, right? Y from before. Now select second is going here into E2. We remove the head. So all we remain is C, CY, select second, X. Now X is going to go inside of C. And now X is going to be applied to Y, is going to be applied to select second. Select second in our case is false. And XY false. So this is really not a step. It was just, I did this. First it was written false. I was just doing this so that, I guess maybe to make some more connection with the way how we achieved false by defining select second. XY false. Right, that's how we get XY false. But it's funny, how do you get from here to here? Yeah, this is very hard to parse. It's almost not like human. think it would be good to read the whole book and understand a bit here and there, then read the book again. And now we have an AND true PQ. The AND itself expands to XY because it will take two things. It's funny, you have AND true PQ. What are the arguments? It's like this entire thing is being applied. Oh, of course. I think actually mentally I'm used to seeing AND true. What is right? I should open up a new tab, Nix REPL. Now, do I have make first? Let's define, so select first again, select first. After a while, I think this will be too hard. I will have to define some kind of library with these functions. That'd be nice. Could I define a library with the functions that I could import into Nix REPL? Okay. So I'm practicing Lambda calculus with Nix REPL. But each time I have to retype, which is nice way to learn the functions, or better to say redefine. Select first, select second, cond, actually make pair, cond and such. How can I can import it. Oh yeah, I can import it. How can I import these functions into the Nix REPL and define them inside directory? So you can define your Lambda calculus functions in Nix file within a directory and then import that file into the Nix REPL. This way you won't need to redefine the functions every time. Here's how you can set it up. Create directory, Lambda. All right. Yeah, let's do this. Okay, Lambda calc. Actually, let's Lambda. Let's move it. Lambda calculus. Okay. CD Lambda calculus. Create a Nix file. Oh, like this. This is nice. Okay. Vim functions. Nix. So let's do this now. What functions? What did we do so far? We did identity, right? We did the identity XX. AB. Are we going to do AA or XX? Identity AA or XX. Let's do AA. Identity. We did apply. A F FA. We did self-apply. We did AAA. I wonder if the self-apply, I don't think it might not work actually. I do this like this, self-apply. We don't actually need it. Apply. I have to fix formatting. Why is this indenting so much? I should fix this in Vim. Yeah, this is apply. What else? Select first. What else did we do? Apply. Well, let's do select first. A, B, A. Select second. A, B, B. Make pair is A, B, C, or let's call it F. F, A, B. And then we do true. True is select first, right? And false, select second. And cond is make pair. Cond is make pair, yeah. Let's do it also with prime, so that select, why isn't it, I wrote something make pair. It's showing select first, but not make pair. Why? I do need this. Oh. Really? Do I really need this? Let's try next REPL. I think it's how do I import it? Do I have to give it a, I can just load, okay. Load functions. Undefined variable select first. I did define it. Select first. Ah, because this is an attribute set. I'm calling something. This has to do with Nix. I'm calling something that was defined. Yeah, okay. Select first. Interesting. It should be like a rec attribute. It should be like a rec attribute. It doesn't work because Nix attributes cannot call definitions within themselves. So I defined true in terms of select first. So the normal attribute set does not pick it up. Can I have a rec attribute set? Probably. If you want to define functions that reference each other, you will need a rec. Yeah, I would just need rec. So like this, identity, now it should work. Select first, let's do it like here, make pair, true. Let's try again. Nix REPL, load functions, added 8 variables, identity 2, it works. Make pair 2 and 3, it works. Make pair 2 and 3, select first, it works. Cond 2 and 3, true. Cond prime 2 and 3, true, it works. Great. So I should functions. So now we have an and we defined and as x, y, false. X, y, false. Not sure if that will work actually. X, y, false. Right? X, y, false. And is x, y? Oh, yeah. There should be heads and bodies. X, y, false. Now, can I just load it again? Yeah, this won't work because of the X. Unexpected, expecting. Oh, so each line, really? Okay, like this. Okay, now it works. And let's test our AND. True, false, true. I again forgot the AND. And true, true, false. Tempting to call something which is not a function. Again, I forgot it. This is going to be a very long series. I think I will have hundreds of episodes of lambda calculus. And this is just the first level lambda calculus. The first level in the sense, it's not even typed. It's simple lambda calculus. I wonder if it's possible to get to the lambda cube, which sounds very, you know, Star Trek like. Lambda cube. N true, true, PQ. And true, 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 and true, true. And true, true, and true, true, true. I see. And true, true, false. It's just weird way how to test and like this. And true, false, because we're not providing it. And true, false, true, false, true, false. Oh, it does. It picks the it's so weird. And true. Okay, and true and false, false. False, false, true, true, true. Let's do like 1 and 2. 2. Or let's do 0 and 1. And false, false, 1, 1, 1, and false, false is the same. It's not about the value. It's funny. This tells us something else. I think this is an abstraction before, like it tells us that false and false, how it works, how it picks things. But we provided things. It's not. It's like I'm used to comparing these two things. But look at this. If it does this, it will always do the same thing, no matter what I give it. False, false will give false. We'll choose the false. We'll choose the select second. Yeah, I don't know how to explain and after all of this time. "23 minutes. And maybe it's just too hard. Well, it's not too hard, but it's maybe trying too much to somehow have the entire evaluation, how it evolves. Maybe let's look at OR. Otherwise, this whole stream will be about understanding and. Let's look at OR. And then we should, I think I'll go back and study again the binary operators. OR is a binary operator of the form operand or operand. So again, it takes two operands. That's why it's called a binary operator, which we will again describe with a truth table, using X for the left operand and Y for the right operand. Again, we have a truth table. And like this, it looks very simple. So simple, you might just think, oh, I get it, and then leave. X and Y. So now we have a different kind, it's a different kind of a thing now. Now we have false and false and false. And I was curious about this. Why would false and true evaluate to true? Because by default, it picks true. And actually, ChatGPT gave me a nice example about rain. So the false thing is, the little true thing is, okay, the false thing is it's going to rain. And what was the example? And the true thing is I'm going to bring an umbrella. So the result is true. I'm going to bring an umbrella because it might rain. It was something like that. False and false gives false. So false or false, of course, it looks for true. It looks for true. So if it's false or false, it will be false. If it's false or true, so there is some true in the false, then we're gonna get true. If it's true or false, this is the same case. It's just different, you know, here is true and here is true. The true is the second operand, here is the first. The result is true. And if it's true or true, of course it's true. So we have 3 trues and 1 false. Only when both cases, when both operands are false, we get a false. Otherwise, we always get true. So note that if the first operand is true, if the first operand is true, then the final value is true. If the first operand is true, then the final value is true. Well, if the second operand is true, the final value is also true. And otherwise, the final value is the second operand. So, oh, this is like the definition. If the first operand is true, then the result is true. Otherwise, the final value is the second operand. So we could describe this using the conditional expression as x. Yeah, I still haven't actually managed to do this on my own. X, if x is true, then y. Now what's this? Using selectors, if the first operand is true, then select true. Oh, now he's doing the same definition using selectors. So this is a common pattern. He defines it in a simple way, and then he defines it using selectors. If the first operand is true, then select true. And if the first operand is false, then select the second operand. Using selectors, if the first operand is true, then select true. And if the first operand is false, then select the second operand. So let's see, defined OR. What do we have here? Lambda x, lambda y. So we have 2 heads because it takes 2 operands. The condition true, y. So true is select first. Condition make pair. So it makes a pair with select first and y. And then x. Yeah, this is still very difficult to parse now. I'm better at talking about it, but it's still very difficult to parse. The way how to do it is actually to just write it out. Write out the substitutions. There is no other way. Simplifying the inner body, there's just no other way. Let's go into our notes. And OR equals what? Lambda x, lambda y. And what do we have? Cond true. Cond true y. Let's do like this. Cond true y x. Okay, so we're going to simplify the inner body. So that's without the okay, let's simplify the inner body. Simplify, I guess reduce would be the word. Let's do, okay, E1, E2, C, E1, E2, close bracket. Did he already do it? C, E1, E2. Okay, he's doing it also. Okay, we can do it as a practice, I guess. C, E1, E2. And then we have true, true, and y, and x, and x. Yeah, I should do it here also. I mean, probably after a while, you really don't need the parentheses once you get the hang of it, how the function application works. And you can make the groupings in your head. So it's some bit, okay. So now E1, E2, C, E1, E2, true. Because it's almost confusing now to do it, right? So first things first, true. We're going to substitute true for E1. Yeah, I don't like these parentheses. We're going to substitute true for E1. So we have E1. E1 will enter the parameter here, E1. True jumps to E1 and removes the head E1. So we're going to have E2, C. Okay, this is 32 minutes. E2, C. And then C, E1 is true. And E2. And I can put this inside at least. And then we have a y, and then we have an x. Right? Next thing, E2, C true, E2, Y, X. Now, what are we going to do? Now the next one is Y. So Y is going to substitute E2, and we're going to drop the E2 head. So we're going to have C and C true Y, and then X. So we have C true Y, X, and now X is going to substitute C, and we're going to get X true Y. So now what was the OR, right? It was X, Y, X true Y. It's funny, like, you define it like this, but then you don't really see this by the can you parse this? Can you see this just by this definition? How did he get to this? How did he define OR? Let's try. Can you help me understand the OR here? Let's break this down step by step, starting from the description and then interpreting the Lambda calculus definition of OR, the explanation of OR, behavior of OR. If the first operand x is true, the result of OR is true, no matter the second operand. ChatGPT is nice about this here because it can give you a slightly different wording and which can help in understanding. For example, even this small thing, no matter the second operand. I can feel sometimes these little vocabulary changes help. If the first operand x is false, the result of OR is the value of the second operand y. Conditional description. Using a conditional x question true y, we express, okay, if x is true, this means if x is true, the result is true. Otherwise, if x is false, the result is y. Oh, I've been reading this completely in a bad way. So this is actually if then true statement. It's a conditional description. If this is a question, if x is true, the result is true. Otherwise, if x false, though that means if it's true, then it's true. Otherwise, if it's false, then it's y. I see. So this is a more simplified way how to express a conditional expression. He's been using this in the AND example, which I think I didn't read it actually properly. Let's make a screenshot of this also for the YouTube video. Conditional description using a conditional. Okay, using Lambda calculus with selectors, we can define OR using selectors like cont, true, and false. Here's a breakdown. So it's interesting, he calls cont a selector. It is a selector. It's a selector. These selectors, they don't. Yeah, even select first if you do. It will output actually. It will output. But if I just do select first, yeah, it just shows where it's defined. Okay. So x and y are inputs. That's what we said. X is the first operand, y is the second operand. Cont true. This creates a conditional expression where if true, branch is true. Cont true. Cont true. So if cont true, that's I guess that's his way of writing this. Cont true and takes a y and an x. I think I'm not actually substituting well. This creates a conditional expression where if true, branch is true. So if the condition is true, the result will always be true. Cont true, true. Cont true, y. Interesting, he comments this, he expands function by function. Cont true, y. Now we construct a conditional. Oh, this is interesting. I wasn't really commenting like this. So this is, so you comment first the inner expression, then the inner being applied to y, then these three things being applied to x. So you don't really look at the head. The head is here, sure, but this is the body. These are the parameters defined. So this is the function name, and this is the body of the function with its heads that define the parameters of the function, and how these arguments, when they get passed to parameters, what are we going to do with those heads? How are we going to do with them? How are we going to, yeah. So cont true creates a conditional expression where the if true branch is true. So if the condition is true, the result will always be true. And then you need to expand one level up to contrue y. Now we construct a conditional where if the condition is true, then return true. Interesting. So here it said if the condition is true, always be true. You see, this wasn't actually mentioned in the book. When you look at it's thing about scope. I think that's the problem when trying to understand this. You see true yx and you immediately put everything in the same scope and you try to understand what you're reading. But the functional application goes like this. First is true. So if you just look at true, this is, if it's true, it will always be true. And that's it. But then once you look at, then you expand, you look at true y. Now, if the condition is true, return true. If the condition is false, return y. I didn't read it like that. So if it's true, return always true. Then we read, if it's true, return true. Otherwise, if it's false, return y. Get it? Get it? Finally, we apply x as the condition to this constructed conditional. It's almost like a meta rule. We apply x as the condition to this constructed conditional. So the constructed conditional is the true y. It has the left thing and the right thing. If it's true, it's true. If it's not true, it's y. But now we have an extra thing. If x is true, the conditional evaluates to true. If x is false, the conditional evaluates to y. Of course, this actually helps. This is the same thing. It's just I wasn't actually thinking about this straight. So before it was said, again, if the condition is true, return true. But here it said if the x is true, return true. If x is true, the condition evaluates to true. Before it was if the condition is true, it evaluates to true. Okay, so we read condition true, it evaluates to true. If the condition is false, it evaluates to y. If x is true, return true. You see, that's the difference. If condition is false, if x is false, return y. Oh wow, yeah, I still do not parse this like this. It's fascinating. You don't actually parse it like this. So if the condition is true, return true. If condition is false, return y. Now we expand to x. If x is true, return true. If x is false, return y. Fascinating. So why would that be or? If the condition is true, return true. What's the condition? Condition is that x is true and y is true. That's the condition. Condition. So we do not know what will be the condition even while here. We only know that if condition is true, it will return true. Here we expand our understanding. So almost like function application is applying your understanding to more understanding. But you always need to carry something from previous understanding to understand the result. It's just not so simple. This is so complex. So condition true preview. So the condition true. If condition is true, return true. If it's false, return y. Get it? And now x. If x is true, now we expand, we include x in our condition. which now applies to x if x is true. Because before we didn't know. While we were here in this scope, we didn't know about the x. So we only knew that if the condition is true, we're going to get true. But now the scope expands to x, which means, right, if x is true, that's the condition itself. If x is true, we're going to have true. If x is false, we're going to get y. But how is that or? Okay, how would that be or? Well, if x is true and y is true. Oh, now you have to practice with every single. I think it's good to do it in your head. Okay, let's say x is true and y is true. Okay, if x is true, we get a true. Of course, because if any one of the operands is true, we get true. So it's not important what y is. So if x is true, we get true no matter what. That's why x is here on the outside. Is it so? If x is true, but first becomes the y. Okay, I think now it will be a good time. Okay, here we were actually x and y conned true y and x. E1, E2, C1, C2, 3x. X, y, x true y. It's funny, it's almost like you do get it, but then you look at the code and it looks not so simple. What is this? Will I get like a copyright? Oh, sci-fi space, 30 tracks game music pack, no copyright. Nice. "47 minutes. Yeah, I'll take 10 more minutes and then stop. I think it's good to do it in small bits. I kind of think this is just good for the brain. Maybe people will say this is not practical at all, but it's good to wrap your... Oh, Frikla wrote back. Let's see what he wrote back. Yeah. I don't know. I think I'll stop now, actually. This has been nice so far to run through. It's kind of cool that I mean, these things I saw it explained very briefly. But it's just, I don't know, it's just way different to really have it in your head like this. I don't know, I think that's okay for now. I'll do it next time more. I'll do more or and and. And let's see just what's coming. Define or, we're gonna do or. And natural numbers. Okay, I think it's very important to really understand how this thing goes, because I've read some of the comments of people who somehow, and I experienced that you start learning this and you kind of understand, but then once things get really complicated, it will really pay in, what is the expression, in dividends, the way you really learn the basics. So I think it's very important to really learn the basics well and to explore more like improvisation with it, so that you are able to almost like improvise the code and write all kinds of things. That's a sign of really understanding something, I guess. Okay, that's it for now. I'll stop talking. Thanks everyone, and that was Lambda Calculus.